You know that glowing rectangle in your pocket? It totally feels like magic, right? You tap it, you swipe it, you pinch it, and it just knows. But here's the thing. It's not magic. It's actually a brilliant piece of physics and engineering that you use all day, every day. So in the next few minutes, we're going to pull back the curtain and show you exactly how it all works.
Let's just start with a number, 2,617. Any guesses what this is? Go on, take a shot. It's not a price tag, it's not a distance, it's something you do every single day, probably without ever thinking about it.
That's it. Over 2,600 times. All those little taps, swipes, and scrolls, it's basically an extension of our own bodies at this point. But have you ever actually stopped and wondered what is physically happening in that split second when your finger meets the glass? How on earth does it know precisely where you're touching?
Okay, so to really get our heads around this, let's start with a simple idea. Forget all the complicated circuits and wires for just a second, and let's imagine something a little more web-like.
Just picture this. Your screen is covered in this tiny, invisible spider web made of electricity. It's just sitting there, perfectly still, waiting. And when your finger gets close, you don't push on the web, you just kind of break it at one specific point. See, it's not about pressure at all. It's about your finger's natural electrical properties messing up this perfectly balanced field.
So, with that web in mind, let's peel back the layers of glass and look at the real anatomy of a touch. How is that electric web even built? And how does your phone feel that tiny little disturbance you create? Well, it all happens in 4 crazy fast steps.
First up, the grid. Right underneath the glass surface, there's a layer of material that's both transparent and conductive. It's laid out in a microscopic grid pattern. This is our invisible electric web. Second, we have the charge. Your phone is constantly sending a very, very small electrical current across this entire grid. This creates a stable, uniform electric field that covers the whole screen. It's perfectly balanced. And third, this is where you come in, the interruption. Your body is naturally a pretty good conductor of electricity, right? So when your finger gets near the screen, it acts like a little siphon and draws a tiny bit of that electrical charge away from the grid, right at the point of contact. This creates a measurable disturbance. And finally, number 4, the calculation. The phone's processor is so fast that it instantly detects the exact spot, the X and Y coordinates of that disturbance, and boom, it registers it as a touch. The whole thing, from start to finish, happens in milliseconds. It's incredible. Now, understanding this whole electrical process is the key to why your smartphone feels so different from, older tech. This wasn't just a minor upgrade, it was a total revolution in how we interact with our devices.
Before we had these amazing capacitive screens, we were all using resistive ones. Remember those? The squishy screens on old ATMs or GPS units or the checkout counter at the post office? You had to physically press down on a soft plastic layer to make 2 points connect. They were clunky, they weren't very accurate, and they could only handle one touch at a time. What we have now, with durable glass that just senses conductivity, is a whole different universe.
And that right there is the absolute game changer. Because that grid can track multiple points of electrical disturbance at the exact same time, it gave us multi-touch. Pinching to zoom in on a photo, rotating a map with 2 fingers, swiping through a gallery, all of those gestures that feel so natural now are only possible because the screen isn't feeling pressure, it's feeling electricity.
All right, now that we've got the science down, let's have a little fun. It's time to bust a really common myth and talk about, well, bananas.
Come on, admit it. We have all done this. An app freezes up, the screen stops responding, and what do? You start jabbing at the glass harder and harder and harder as if you're trying to physically force it to listen to you. But does that actually do anything?
Yeah, not a thing. It does absolutely nothing. This is one of the biggest myths out there. Just remember, your screen is an electrical sensor, not a pressure plate. Pushing harder doesn't make your finger any more electrical. If your screen isn't responding, it's way more likely that your hands are just too dry or the screen is dirty, and that's interrupting that delicate electrical connection.
And this whole principle of conductivity leads to some pretty funny results. Because your screen is just looking for anything that can conduct a little bit of charge, you can, and I'm being serious, you can operate your phone with a banana, or a hot dog, or an orange. They all have enough water and electrolytes to work. And on the flip side, this is exactly why your standard wool gloves don't work. Wool is an insulator. It blocks your finger's electricity from ever reaching that grid.
So the next time you fire off a text message or you're zooming in on a map, just remember that invisible electric dance that's happening between you and your device. It's a technology that took one of the simplest human gestures and turned it into the command that runs our entire digital world. Which kind of leaves us with one last thought. If the humble touch completely defined the last 15 years of tech, what simple interaction is out there, waiting to define the next?